It says, Mr. Adler has 400 cows when a virus starts killing off his livestock. There's a typo there. Sorry about that. In 6 weeks, he has 200 cows left. Write the exponential model to predict his cattle population. So what will that look like? It can look like the function p of t equals p naught for the starting amount times a raised to the t. So let's don't get things too mixed up here. P of 6. Okay, so we have the information about what happens 6 weeks in is 200. Okay, the starting amount is 400, so that's a little bit backwards, so that means it's a decay. Okay, and then t is 6 weeks. So what we're going to be looking for when we do this is going to be the a. I'm trying to erase this 6 and make it prettier. So we're looking to find the a. So let's see here. We'll fill in what we have. We have that we end with 200 cows after starting with 200 cows times some unknown rate after 6 weeks. Okay, so we need to find that a. So we can divide by the 400. So we will have 200 divided by 400. So that'll give me 1/2 equals a to the 6th. So let's go in and let's take the 6th root of each side. Okay, and after that we'll have a is equal, well, approximately, since this is not going to be a nice number, so 0.5, and we're going to take the 6th root. I'm going to round it to 4 decimal places. That may be enough. 0.8909. Okay, so I have an a. So the function that I want will be p of t, meaning I can pick how many weeks in I want to go, equals 400 times 0.8909 to the t. So I can plug in t for a number of weeks, and I will get an output as far as number of cows that are left. And remember that if this little a, this rate, is less than 1, then it's a decay, meaning we're going to have less and less cows left over time. Thank you.